1945, Italian dictator Mussolini was approaching the end of World War II as part of the Axis powers. As war approached the Italian front, Mussolini was toppled from power and the fascist cabinet was hunting him down. However, after only a few hundred meters, Mussolini was dead tired while his captors were still full of energy. Eventually, he got caught and executed. Why is this so? This is because he got very tired easily, which is because of his anemia condition, and more specifically, it is caused by his beta thalassemia. And what is beta thalassemia? We'll find out now. It is one of the most important proteins we need in our body. It is found in our red blood cells and it has 4 prosthetic groups that enables itself to bind to oxygen to form oxyhemoglobin. This transports the oxygen throughout our body and gives us the energy we need during cellular respiration. So yeah, it's pretty important. Anemia is the reduced production of effective hemoglobin in the red blood cell. And this causes serious effects, such as in Mussolini when he got executed. Actually, his cause of anemia is quite specific because it is caused by beta thalassemia. So what is beta thalassemia? It is caused by a gene in the chromosome which causes the formation of beta chains to be faulty. So you see, in hemoglobin we have 4 chains, 2 alpha and 2 beta. And beta thalassemia is the faulty production of the beta chains itself. This production of hemoglobin in the red blood cells itself. And this is extremely serious because in the case of our fake story of Mussolini just now, the cause of his anemia is actually by its beta thalassemia. So what is thalassemia exactly? Thalassemia is actually is caused by a gene in the chromosome. When this gene causes the formation of the beta chains in hemoglobin to be reduced or absent, those beta chains, the hemoglobin cannot be formed properly. And the carrying capacity of the blood, the carrying capacity of the oxygen in the blood is affected. So the person will feel fatigued more easily, and when he does anything strenuous, he just gets tired. And because beta thalassemia minor is a form of incomplete dominance, as long as you have one allele with that gene, you will be affected. And they are incomplete dominant because of the strength in alleles. The dominant allele and the recessive allele are almost the same in strength, and that causes the beta thalassemia in humans. On the other hand, it's caused by a homozygous condition in this recessive gene which causes the faulty production of beta chains. So people with beta thalassemia major will have a significant decrease in red blood cell production, and the impacts are much more severe than just a minor case. So people with major, they won't survive to adulthood, so good luck to them. Anyway, people with beta thalassemia minor needs to be able to understand that they cannot be doing strenuous exercises. But beta thalassemia is by nature autosomal recessive, so it is not sex-linked, and it can be appear in anybody with this trait. And because of its incomplete dominance, whether or not you have another trait with normal gene or not, you will still experience symptoms. So how do I treat beta thalassemia? With those with minor cases are less serious, it can be treated by injecting iron into the blood to solve the issues of heme production. But for the major scenarios, the beta thalassemia major cases, we definitely need something more major, right? So a bone marrow transplant would probably be the only hope for such patients, because a bone marrow transplant would give them functional red blood cells to carry oxygen. And this may just increase their survival into adulthood. Beta thalassemia is actually asymptomatic, which means there are no physical conditions which you can observe. A bit of the origins of this beta thalassemia condition. In ancient Italy and Greece, malaria was very widespread, and malaria was caused by a parasite transmitted by the Aedes mosquito. And beta thalassemia reduced the production of red blood cells, so the chances of the parasite spreading decreased together. So in ancient days, beta thalassemia was actually an advantageous gene. But of course, in the modern society, it is a deleterious gene. Yeah, deleterious gene. So, however, now we have a new hope. With the new gene editing techniques known as CRISPR, the gene can be changed in the fetus itself so that a baby born would have a normal condition, as shown here, without the autosomal recessive gene. With CRISPR, people can be born without this condition, and it could potentially save thousands of lives, hundreds of lives, I don't know. But yes, so this gene itself can be removed through CRISPR so that people are born with a functional production of hemoglobin. The disease can be wiped out in just a few generations. So beta thalassemia minor is just a minor hindrance, but the major one is quite a major problem. And hopefully this can be solved due to the power of sciences, and that is what we should take away. Okay? Science is powerful, and Italians are very bad at running. Thank you for listening to our fake story on Mussolini, and I hope you learned something about beta thalassemia. It is really great to have you here listening to my informative video, and I hope you liked it. Please like, comment, subscribe. By the way, Spider-Man time.